Okay. Welcome, everyone. We want to thank you for joining. If you have any questions as we go through this webinar, please feel free to post them to the Q&A section and we'll respond to them. I'm John Harrington. I'm the Chief Business Officer of HighButt, and I'm joined by Aaron Simile, who is the Chief Technology Officer. Today, we're going to talk about HighButt, Unified Namespace, Cloud to Edge, and some new use cases that we're delivering through Industrial Data Ops. So the agenda is to give a brief overview of the HighButt Intelligence Hub and the advantages of a data ops solution, and then to quickly get into some demonstrations that Aaron will be leading of Cloud to Edge using AWS IoT Core, pushing data down to on-premise systems, leveraging a database to a UNS, and then some CSV to various other systems. HighButt is a software company focused on providing data infrastructure solutions to manufacturing companies who are looking to achieve their industrial transformation goals or to achieve Industry 4.0. The HighButt Intelligence Hub is a data hub that connects many systems. It supports multiple protocols, OPC UA, MQTT, CSV files, SQL, REST, as well as direct connections to Microsoft Azure and AWS. What's unique about the HighButt Intelligence Hub is that it has a data modeling engine at its core. With this modeling engine, you can create models for your assets if you want to do predictive maintenance, or you can create models for your products if you want to do traceability or quality analytics. You can really create models for any use case that you need to obtain, and then deliver the data to any system that needs it for that use case. The HighButt Intelligence Hub is designed to provide the linkage between the OT team and the IT team. It's a solution that was designed for the OT team to be able to consolidate the data from the OT, from the industrial systems, and standardize, normalize, and contextualize that data, then deliver it to the systems that need it for the use cases that need to be achieved. One of the key challenges that many companies are facing as they adopt Industry 4.0 and as they evolve their industrial systems to today's world of work is that there's a lot more systems that are looking for industrial data. The key challenge of these systems is how do we integrate them efficiently and effectively and deliver data that's able to be used quickly and do this in a maintainable fashion. The point-to-point connection has become a challenge and has been a huge distraction for many teams in supporting this data needs. At the same time, industrial data is challenging to use. We've seen challenges both in new use cases that need access to the data and it not being structured the way you need it, a lack of standards and normalized data, and a lack of context of that industrial data. The benefits of using an industrial data ops solution span both the OT team of being able to contextualize and package up this data efficiently and manage that over time as they make changes on the factory floor. The IT team who needs to be able to consume this data and deploy it into various systems, whether they're on the cloud or on premise. And then the users of this data, whether they're data scientists or engineers throughout your corporation who need access to the data and need access in the systems that they use. So again, that's a brief overview of the HighButt Intelligence Hub. At this point, I'm going to turn the webinar over to Aaron Simile, who's going to talk about a few of the key use cases that we've been able to deliver with our new version 1.4 of the HighButt Intelligence Hub.
Awesome. Good morning, everybody. Morning here anyway. I got my coffee here. John, could you just enable me to share my screen, I think? Then I'll walk you guys through some of the new capabilities here and There we go.
Did that do it, Aaron?
Make sure I get, yep, I got it. Make sure I got the right. Let me know when that comes up.
It's up.
Are we in?
You're good.
All right. So I'm gonna cover 3 use cases in this demo, and really, I mean, we had a ton of capability in 1.4. It would be like a 3-hour demo for me to show you all of it. So I'm gonna move fairly quick, but I'm gonna cover 3 use cases. I'm gonna build them from scratch. So the first use case is taking SQL data and getting that into the unified namespace, right? So unified namespace full of process data from the PLC, but a lot of data in the factory is locked up in SQL, specifically in the MES system. You get asset information, batch information, et cetera. So you want to make that a first-class citizen in the UNS. So I've got a SQL database locally installed, Microsoft SQL, and I've got an asset database, really simple, right? Asset database, it's got an asset ID, running minutes, so some kind of OEE-like data and a part count. And I just have three rows in this database, just for the example. So the first thing I'm going to do in HighByte is I'm going to go create the connections. So I'm going to create a connection to my local SQL server. And I'm actually running this on a Docker image, right? So I've got HighByte running in Docker. So my IP addresses are going to look a little weird because I've got to connect from the Docker image back to my host. So it's going to be host.docker internal. My database is called test. My username is my name, and then my super secret password, 1234. And then once I have that created, I'm going to create an input. And in here, we have the Object Explorer, which this shows the connection worked. I can see the tables and stored procedures. We added that to 1.4, the ability to browse stored procedures. You could call those before in 1.3 from the query, but to browse. Then we also added the ability to drag and drop from here, right? So I can say, select everything from assets, and then execute that query. And you can see it returns multiple rows, but it'll only show the first row. So you can see that's the first row. So I'm going to create one query that returns everything. I'm going to clone this. I'm going to create 2 more queries. One that returns information specifically for press 1. You can see I'm just writing SQL in here, asset ID equal to press 1. And again, I can execute that and make sure that works. You can also in here expand the table and look at the columns that are in there. So if you didn't know what asset ID was called, you can do that. So I'm going to save that for press 1, and then I'm going to clone again press 1 because we had a press 2 in there. And I'm just going to change the query to press 2, execute. And you can see that's returning the data for press 2. So that's my connection into SQL, and I verified that that's returning the data. Now I'm going to connect to my UNS, which in my case is an MQTT broker running on my local machine. So unified namespace is awesome. I consider it a concept. The technology behind it in this case is the MQTT. So I'm going to again connect to host.docker.internal, and this is an unsecure connection just on 188.3. I'm just going to call this Aaron demo. Again, no security on this one. And I'm going to create an output because I want to publish that SQL data into this UNS. So I'm going to call this, I'll just call it assets. And then my topic, I'm going to stick to somewhat of a ISA 95. So I've got my company name. I'm just going to call it company, site 1 packaging. And then a feature we added in here is I'm going to put in a £. What you'll see is this is going to take the instance name that we haven't created these yet, the instance name in HighByte, and it's going to put that in the topic path to kind of segregate the topic path by instance. So I'm going to save that. Now what I want to do is go create my model. Now I could take the SQL data raw and push it into the UNS and use the column names that are there already. But in my case, I actually want to model those. Oh, it's not a completely new instance. I'd already created these. So I have a model called asset, right? It's got an asset ID. It's got running minutes. So this is an example of, I'm going to change the column name. If you remember down in here, the column was running minutes. I'm just going to call it running time minutes. Just as an example, I can change the column name. And then part count, I'm going to leave the type to any, which means we're going to take the data type from the SQL database and pass that along, but I could change the data types and we would transform it. So I already have my model. So what I'm going to do is I'm going to create an instance of that model. I'm going to call this press 1. and it's based on the asset model. And here, what you'll see in 1.4, we did a lot of work to improve the reference browser so that you can easily, after I create those inputs, right, I can just kind of dynamically grab press 1. You see it returns a single row. You see the columns that row returns, and I can just drag and drop those over. So pretty cool. So that fills out press 1. I'm going to save that. I'm going to go back to models, instances. I'm going to create press 2, which you'll remember was in there based on the asset model. Just like before, very similar. Press 2, running minutes, part count, and we're in. So I've got my connections. I've modeled my data. I've created instances using those inputs, and now I'm going to create my flow. So this will send the data. So I'm going to say SQL. I'll say assets to UNS. So here I'm going to take those 2 press machine models that I made, the instances I filled out. Those are my inputs. You'll see in 1.4 we added, we call it multiplexing, so the ability to have multiple sources and targets, which is pretty slick. And then I'm going to send that out to my assets topic over my UNS. And here I'll just say send it every 5 seconds. And if I did that right, I'll pull up use MQTTFX for my client, pull up my client, connect, and then it publishes every 5 seconds. So we should see something pretty quick. Oop, if we subscribe. There we go. One second. Oh, you know what? You got to turn the flow on. There it goes. There's my one bug in the demo, John. Subscribe, pull this over. Here you go. That's an easy one to solve, right? So you'll see press 1. So remember, we put that hashtag in the topic namespace. This is taking the instance name out of HiByte and throwing that out to the MQTT namespace. So press 1 and press 2 are in here. And if we click between them, you'll see this is the model definition with the column rename. The other thing you can do, which I'll just show quick, is you don't necessarily have to use a model, right? So I can open this back up, and you'll remember I had one of my inputs in there was all. So I was grabbing all the rows out of the SQL database. So I'm just going to drag that over as another source and save it. And we'll pull this back, and what you'll see is you'll see another one appear in here. Turn on the auto scroll quick, turn it off. So you'll see this MS SQL, which was the connection name, all was the input name. So that got injected where the pound sign was, but you'll see the output is now each row. So it's a JSON array of each row worth of data. And we could, I could extend this and show you how you could do we call it array expansion. So you could actually run each row through the model, through the instance, transform it, and then output the array. We can do that as well. But this is just a quick example of a direct input and what that looks like when you wire it to the output. The only thing I want to cover there, one thing we're working on actively right now is the ability to what we call parameterized inputs. So it's the ability to, in here where I created separate inputs for press 1 and press 2, it would be the ability to make this a dynamic input where you could reference, and we're figuring out how best to do this, but you could reference like an OPC input, tag 1, and use that to parameterize the query. That's something we're actively working on now that we'll probably have available in the next few weeks or so. So if you're interested in that, we have a number of customers that are in early access to it. Just ping us and we can get you in early access to that feature so you can help test it out and give some feedback. But yeah, that's it. So that's taking SQL data, like transforming it, pushing it into the UNS. So that's use case number 1. The second use case I want to show you is what we call cloud to edge. So this is, I have some data in the cloud and I want to bring that back down to the edge and inject it into my SCADA system. And in this case, a classic example of that is I have some machine learning algorithm in the cloud. It's going to identify an issue and we want to send an alert down to the factory, and we want that to show up in the HMI, for example. So what I'm going to do here is I'm going to demo this using the technology IoT Core from AWS. I'm going to create an MQTT input to connect out to IoT Core, pull in the alert, and then I'm going to send it out via Sparkplug B and OPC UA, so it lands in Ignition and Kepware. I think that's it. Keep me honest, John, if I don't do all that. But, all right. So the first thing we got to do is connect to IoT Core, right? So AWS IoT Core. That connection uses MQTT, and I've got my IoT Core account here. So I've got to grab the address, which is here, of the broker. And IoT Core is like a giant MQTT broker, and it uses security. So I've got to use 8883. And then client ID, I'm just going to fill that in. And it uses SSL. So there's a separate video on our YouTube site of how to go get these certificates and kind of the setup. I think it's like 7 or 8 minutes long. I've done this in advance, so I'm just going to copy the cert names over. And right now we have some batch files that help you bring these certificates into our certificate store and then reference them by name here. And that's what that video essentially shows, and the AWS side of how to go get them. In a future release, you'll see you'll be able to do that through the web interface, upload certificates and whatnot, probably in 2.0. But so this is my credentials to connect in. And what I'm going to do is create an input. I'm just going to call it all, and I'm going to subscribe to everything. I'm going to read that input, and if I did it right, you'll see the error come back, say no value in the cache. It means we've connected to AWS IoT Core, but it hasn't sent us any data, so there's no value for us to return. So that looks good. So I'm going to submit that. And then to create that value, I'm going to use the AWS IoT Core test client to publish out. So I'm going to publish to a topic called alerts. And here I'm subscribed to everything on the HiByte side, so the topic name won't matter. And I'm going to change the message to press machine is too hot. And then I'm also going to add a reading in here. Oops. And just call 100.1. I'm going to publish that. Now this is publishing through IoT Core, and then HiByte is sitting on the other side, subscribed to it. So if I hit read now on this input, I should have gotten that message. You can see there it is, the message in JSON format. So that's good. So I've got my input. So I'm going to model this. You don't necessarily need to, but I've modeled it in alert with a message and a reading. Again, using the any type, so it'll be a string here and a number passed down. And then in terms of usage, I'm going to create an instance of this, just called press one alert. It's based on the alert model, and I'm going to go grab the AWS IoT Core input and expand that, and you'll see that you can reference the data model. So again, I'm just going to drag and drop those readings and save that. So now I've got it mapped to my model. Now I need to get it out to Ignition, and I want to get it to Kepware. So we'll start with Ignition, which supports Sparkplug. So I'm going to call this Ignition Sparkplug B. And in here, I'm going to grab the Sparkplug connection. Again, this is that weird address, and I'm using Mosquitto of a local broker, but I'm communicating over that with Sparkplug. So I'm going to set that up. No security in this case. It's local. So what I'm going to do is I'm going to create. Oh, one thing I missed. In Sparkplug, I need the group ID and the node ID. In this case, I'm just going to say AWS, and I'm going to call it alerts to publish. And then I'm going to create an output, and in that output, I'm just going to call it alerts, and I'm going to give it these pound signs for the device ID and metric name, which means it's just going to take the model instance and use that for the device ID and metric name in the topic namespace for Sparkplug. And you'll see what that looks like. But I'll submit that. So I've got everything ready for my flow. So I'm actually I don't have to, but I'm just going to turn this one off. And I'm going to do, what am I doing? I'm doing AWS to SCADA, call it that. And what I'm going to grab is I'm going to grab that instance, which was the press one alert, and I'm going to output that to Ignition Sparkplug B's alert topic. And I'm going to set that off every 5 seconds. And I'm going to remember to turn it on this time. All right, so with that going, this should be grabbing that data from AWS IoT Core, publishing it out via Sparkplug under AWS alerts, the group ID and edge node ID. And I've got Ignition's client here. And let me just refresh. If I go to edge nodes, here's AWS, here's alerts. There's that press alert one, that's the instance name that's coming from HiByte, and here's the message, the machine is too hot, right? And if I go back up to IoT Core and change this to like 99.9 and hit publish, think it was on a 5-second interval, but you'll see pretty quick that comes down. So it's coming all the way back down through HiByte, being modeled and being pushed down to the SCADA system, right? So now in Ignition, you could use this to drive your screens, to generate alerts, all the functionality Ignition supports. So the other thing I want to do is I actually want to send it out via Kepware. So in Kepware, I just created a simulator driver for this to land. But I've got an alerts device with this press one alert tag group, and in there I have the message and reading. And one of the things we added in 1.4 was the ability to push a model out to Kepware. It's a little specific on the naming convention in 1.4. You'll see that press one alert is the same name of the instance I defined in HiByte, and message and reading are the same name of those attributes. And that's important because that's the way we map the complex data object to tags in the Kepware address space. But it's, if I deleted reading, message would still go. So it doesn't require the entire model to be there. It'll just pick and choose pieces. But you'll see, so I've got this defined in Kepware. And the way I'm going to do this in HiByte is I'm going to create a connection out. We'll call it Kepware. And then OPC UA is what I'm going to use to connect. I'm going to use host.docker.internal and ports 49320. I have no security. This connection, it's local. And this is where the magic is. So I'm going to define an output, and I'm going to browse the Kepware server, and I'm going to go to that AWS alerts group. And in here, I have the press alert one, but I want to choose the tag group. So we added the ability to import the tag group, which is alerts. And if I import that, now what I'm going to do is inside this same flow that I'm sending to Ignition via Sparkplug, I'm going to grab an output that is Kepware's AWS alerts tag group. And I'm going to save that. And what you'll see when I launch the quick client and go to here, you'll see we're taking, since the model, the instance name is press one alert, and then these are the attributes reading and message, we're mapping those down to the tags in Kepware. So if I go back here and I change this back to 300.1, just like in Ignition, you'll see that update within 5 seconds. You'll see the same thing in Kepware. So this is pushing data into the OPC server, which then you have access to it to feed it into HMIs or wherever else it needs to go. So that's pretty cool. So that's the second use case, right? Cloud to edge. How am I think I'm doing okay on time. We'll do the final use case here is a CSV input to the UNS. So kind of like we did SQL to UNS, but I'm going to show you a new CSV capability that we added in HiByte in 1.4. So I've got some CSV files on my local disk. Let me show you those quick. Here we go. And I've moved these onto my Docker image for this demo, but they're the same files. So I have one file that this is test data, right? Really simple test data. I have one file that's static, which just has one row, and let's just say that row gets updated. And I have these other files which are history, which contain multiple rows. And there's no timestamp in here, but typically, this would probably contain a timestamp in live data. So what I'm going to do is I'm going to create a CSV input in HiByte, and I have to put in the file directory, and this is on my Docker image, which is Alpine based. So user local HiByte runtime data, I think is where I put it. And then we have these processed and error directories. So I'll show you there's two modes we can work on a file. We can either read it statically, which means we read the same section over and over, or we index the file, which means we read the file in chunks. And then when we finish a file, we'll move it to a process directory. If you don't want to do that, you just leave these blank. But I'm going to fill these in just for the demo. And yeah, all right, so I'm going to go create my input. And the way this works is I'm going to call this static. And this is a regular expression that we'll use to try to match the file. So I believe this file, I called it latest. Yeah, let's just call it latest. So here I'm going to match anything, but it's got to end with latest.csv. And I'm going to do a test read there. And you'll see that it's bringing up the CSV data. It matches this, right? And we're pulling that data from the file. And the other thing we're doing is we add in the file name. So you have the context inside of modeling of what file it's coming from. If there's metadata in the file name, you can pull that in, and also the row number. So here I know that this file only has one row, so I'm just going to set these just to be strict. and I'm going to save that. I'm going to create another input that grabs history data. And it's very similar, but I'm just going to call it history.csv. And when I do a read on that, you'll see it's going to return multiple rows. So this row number that we generate is going to increment. Then I can control how many rows it returns. So I'm going to say 5. And I'm going to index this file, which means I'm going to read it in chunks of 5. And then when I get to the end, I'm going to stuff it in the process directory. If I encounter an error, I'll move it to the error directory. You can tell us how many max rows you actually want to read. So if there's junk at the end of the file, we won't go past that. You can replace the headers, etc. But for the purpose of this demo, I'll save that. So now I could go model this data, right? So I could go into the instances in HiByte, just as an example, and it's going to be available in here, just like it was, history. There's multiple rows, and you can map the data accordingly. Latest, same thing. But I'm just going to send it to the UNS as is in this example. So the last thing I want to do is I want to create a separate separate topic space to place this in the UNS. So I'm going to create another output on that MQTT connection. I'm going to call it test data. I'm going to go back to flows. I'm going to create test data to UNS. And then I'm going to grab the inputs directly, right? So I'm going to grab the history data and the latest data, and I'm going to output that to the UNS test data topic. And I'm going to send that out again every 5 seconds, turn that on. And if I grab my MQTT, I use MQTT-FX, and on 2 monitors, if I drag it on my bigger monitor, it doesn't work at all. So let me clear it out over the monitor that works. So you can see, so I'm publishing the test data in. You can see, here's the static file, right? And then here's the file that we're reading in chunks. And you can see this row number is increasing, 20, 21, 22. There's the static. And then if we jumped again, 25, 26. So you can see it's actually indexing and reading through the file. I'm not transforming the data at all, but again, you could run this through the instances to transform the data, to model it. You could mix it with other data sources, all the things that HiByte supports just inherently. So the very last thing I'll show you is let's say I've got that working, but I also want to log this data out to SQL. So we improved the SQL support in 1.4 quite a bit, and we allow you to not only create an output, but we'll create the table for you. So I'm going to define a test data output table, and I'm going to tell it to create the table. We can actually log the object as JSON in this version too. So like in this, we'd log the JSON version of this to the table. I'm not going to enable that, but that's a good way if your schema is constantly changing because you haven't have it quite nailed down, and you can work with JSON natively out of the SQL database. It's kind of a good hack, a good way to get around those schema changes initially until things kind of settle down. But anyway, I'm going to create the table. Hit submit. I'm going to go back to the flow, and in real time, I'm just going to grab that test data, put it as a target, hit save. Everything's still running. I'm going to refresh over here on SQL. And there's my test data table. And if I select, you'll see, bam, there's the data. Right, so that same data I'm sending to the UNS, I can now cache that locally in a SQL database. Maybe I want a level of redundancy, maybe another application wants access to it and it prefers SQL. In here too, I can, we include metadata like the timestamp, the name, that the name is like the model name. In this case, we're going direct to the input, so it's row. But if I don't like that, I could just go into the designer. How do I do it? I could delete this. There you go. Delete that row in real time, and HiByte will respond to that dynamically. So we'll continue to log and just not include the name. Same for the other fields. So you can kind of create the table initially, and then go in and modify it to your heart's desire. So I think that's it, John. I think I did everything I said I was going to do. If I didn't, let me keep me honest. But I think with that, we can take questions.
That's awesome. Let me take back control. You want to stop sharing, and I'll start sharing.
Got it. Let's see. There we go.
All right. Share. That was awesome. So as Aaron just showed you a few different scenarios he was able to get through, and how we're able to complete each one of those. This is just showing a lot of the features that we've added to version 1.4. There's a lot of information in there, a lot of new stuff that Aaron showed. We'd be happy to give you a more in-depth description of these. You can get the release notes from our website, and we'd be happy to walk you through if anyone has any specific questions or wants to see anything. Finally, I'd just like to say thank you to everyone for joining. We're going to open up the Q&A in just a second, but I also want to thank Aaron for doing those tremendous demos. Also thank the marketing team, Tori Penarcamber, who's been behind the scenes answering some questions that have come up, and was involved in setting up the logistics, and Sarah Payne, who's also involved in setting up the logistics of this webinar. I want to thank you all for coming, and we look forward to answering any questions that you have, as well as following up after this presentation. And feel free to reach out to either Aaron or I. Feel free to go to our website to learn more about this release, or our YouTube channel, where there's a lot of great videos that we've been putting up on how to use certain features. With that, I guess we'll turn it over to the Q&A.
Hey guys. First of all, great job, Aaron. If the only demo mishap you have is not enabling a flow, that is pretty slick. You had a lot of open apps. So I'm going to, we had one question come in, I'll start here. Can you clarify, are you using a HiByte MQTT broker or a third-party broker?
Oh, this is a great question. So we're using a third-party broker, Mosquitto. We know there's a lot of interest in HiByte being a broker or working more inherently with brokers, and we're really interested in those discussions. We're not quite sure what the market need exactly is. So if you're interested in HiByte being a broker, we definitely want to talk to you to kind of ask like what that is. Does that mean that HiByte just works more integrated with existing brokers, or you need some other kind of capability? We do, I probably shouldn't say this, but in 1.4, we do have a broker embedded, but it is essentially a third-party broker that it's no different than if you installed Mosquitto or anything else. We'll just launch it and then shut it down. So that's for like really simple edge use cases where you don't want to install and manage a third-party broker. We have some customers doing that. You can't enable it through the UI. So it's like a settings file change that we'd have to send you. If you're interested in that, we can talk and show you how to enable it. But I don't think that's what people mean when they say, is HiByte a broker? But we definitely want to have those conversations. So reach out.
Great. Okay. I have another question here as well. So does HiByte support Azure IoT C2D messaging as well as AWS? How would a controlled messaging be sent to a machine instead of just an alert? Is that a valid use case?
Yeah, completely a valid use case. We don't on the Azure side yet. We connect to Event Hub, but we don't have a direct path to go from cloud to edge. That's something we could probably pretty quickly enable though with the Azure SDK stuff. So there's not a huge concern there. We'd definitely be interested in the use case. In terms of when you get the data from the cloud going direct to a device, yeah, that's definitely a valid use case, right? And the way we would do that today is we would go through OPC UA, which would then write out to the device, or Sparkplug to like Ignition, which could do it as well. But yeah, we definitely see that.
Great. There's also a question here about array fields. So I know in 1.4 we added array handling. Can you just share a little bit more about and that feature and how it might be used?
Yeah, totally. I kind of skipped over that, but 1.4 is now like totally array enabled, right? So we can take arrays on inputs, you can use arrays in expressions, and if the outputs support arrays, we'll move those arrays along as well. So you can do things. There is a video that I put together on the YouTube channel of how to take primitive tags, turn those into an array and an expression, and then move those out to the UNS. So, and then you'll see inside of our modeling engine, we have an isArray flag now. So like you can set an integer 8 or like an int 32, and then if you click the isArray flag, we'll treat that as an array field. So like arrays are native throughout the product.
And Aaron, that spans not just OPC, but it goes across the connections, right?
All of them, yeah. Anybody that supports arrays, right?
Yeah.
There are certain, like Sparkplug does, but Sitewise, as an example, doesn't support arrays today. So if the end interface does, we'll definitely support them.
Looks like there's a follow-on question to that as well. So can you model incoming data to a model with an array of child models?
Yes. Yeah, it works. So like inside of your expression engine, if you get a JSON payload that inside a child model is an array type, you can use our expression engine to go in and reference that array type, treat it like a native array. So you can get the first element, you could split it and get the first 3 elements, anything you could do in JavaScript on the array. And then you could move that onto the source as well. When you get into a hierarchy in then arrays, a lot of systems aren't, external systems aren't going to support that. So for example, if you try to take an embedded array today and output that to SQL, what we'll do is we'll just show an error that says, hey, arrays aren't supported in SQL, because there's no way to like inherently map that.
We do support SQL inputs. Your input can now be multiple rows, and then we essentially treat them as an array in doing what Aaron just stated, where we can process it through the instances, and then we'll just create an array of within the JSON coming out. So
yeah, and that we showed that, or I showed that off. That's what was going on in the CSV example, where I was pulling 5 rows, dumping those in SQL in a batch write statement.
yeah.
Yep.
I've seen some questions specifically about the UNS, but before UNS being sort of an abbreviation for Unified Namespace, before we jump to that question, I guess, sometimes it comes up, and so I'll pose it here. Is HiByte Intelligence Hub a unified namespace? Are we sending information to UNS? Like, what kind of different architectures are available with HiByte Intelligence Hub, and what are we seeing customers do?
I think we're seeing people defining UNS a few different ways. Some people see a UNS as an MQTT broker, and they're very focused on putting all of their industrial data into a single MQTT broker and then allowing any system to subscribe to that data to pull it back out. They're often following the ISA 95 model for structuring the data in the UNS so that they can logically organize it. In that situation, we see ourselves as the enabler of the publishing, as well as the enabler of the subscription for systems that don't already support MQTT, as well as systems where we want to perform any modeling changes to the data. So in that case, that's where we would kind of surround the MQTT broker and provide that level of capability. Some people are thinking of a UNS as a data lake in the cloud, in which case we can be the publisher into that data lake in the cloud, and we can structure the data as it gets published in. So again, we can pull the data from multiple different systems across different protocols, structure the data, merge it together, standardize it, and then push it up into that cloud data lake, and that becomes the unified namespace. And finally, I think some people think of a unified namespace, it's just a way of modeling their data as they're integrating multiple systems, in which case HiByte can be the UNS. HiByte can provide the linkage between those different systems, and we can model the data. So if they're just trying to integrate 2 or 3 or 5 different systems and don't want to necessarily publish it into a third-party broker or a third-party data storage system, we can be that UNS where we structure that data on its way through. And we'd certainly be interested in speaking with people more about that and how they're thinking about a UNS and how they're thinking about how we can fit into their model.
John, so another question for you, as far as licensing goes, just sort of a practical question here. How does HiByte offer, a free trial or some testing environment that someone can use for learning, pilot projects, et cetera?
Yeah, great question. So we do offer a free trial. You can sign up on our website, or you can email out to us, and we often like to just give you an overview of the solution, and then we can get you started. You can install it local. We don't today offer any cloud-hosted trials, but it is something that we've contemplated for the future. There isn't a 2-hour timeout, so we do require that you reach out to us, give us your contact information, and then we'll just work with you as you're evaluating the Intelligence Hub for your needs.
Great. Okay. Here's a question about, this one says, what do you generally use to historize the topics if not using SQL Server? Can you log to a cloud database?
Aaron, you want to take that one?
I was just typing a response to that one
Sorry.
differently to Sean. Yeah, so my personal opinion, like this is a missing part of the story of the UNS, right? There isn't a lot of great solutions for historizing UNS data. I think like Canary Labs is a good example of being Sparkplug enabled and being able to kind of fill that space. Like, but I think in general it's a missing link. So what we see is we see people trying to use SQL Server kind of first form, right? But where you run into trouble is the structure and trying to store that structure in SQL. So you either have to flatten it out or you have to do some crazy table linking. So it kind of breaks down. CloudDB or document databases, I think from a technical standpoint are better suited to store the type of data because they can just inherently store JSON. But you see people experimenting with them, but they weren't intended for the purpose. So you don't see it a lot in production yet. But I think that's probably the future is more like CouchDB, CloudDB, MongoDB maybe. InfluxDB, we have a webinar coming up with them. They're another alternative to trying to store that structured data. And then the other part of the UNS is, well, how do you pull that back out, right? How do you get that structured data transactionally back through the UNS to folks that need it? And we're actively in discussions with customers and trying to figure that part out as well, because it's not necessarily part of a standard, but it's definitely possible. And I think you'll see in the future a standard emerge. Yeah. Good question though.
I have another great question here. I love this one because at the end of the day, you know, the technology doesn't run itself and it's relying on people and process and how we all work together. So here's a question from Zachary. So my IT counterpart is not aware of unified namespace, MQTT, et cetera. I'm in OT and just setting up a proof of concept. So do IT and OT share ownership of the UNS? Who's the user for a product like HighByte Intelligence Hub? So kind of like what's like the data contract or like process for sharing information and who's the key user of a product like HighByte Intelligence Hub?
That's another great question, and it comes up a lot. So the way that we think about things, and I will say this varies, the way that IT and OT are being structured today is varying. It seems to be a moving target. Some companies are merging the teams, some companies are keeping them separate, but OT is reporting up through IT. Sometimes they're both reporting through digital, and sometimes they stay separate but work closely together. The way that we think about it is that IT and their customers, so maybe the quality engineers or the data scientists or the various consumers of the information are really the customers, and they often know the structure of the models that they need access to. So, you know, quality may say, I need these 10 data points coming from this type of machine so that I can evaluate how it's doing from a quality standpoint. That then gets communicated to the OT team. And we think of the HighByte Intelligence Hub as primarily being owned by the OT team. And the reason that we think that way is that they're the team that really has to understand all of the underlying data tags and all the underlying data sources and the nuances of that data so that they can structure it appropriately and make sure that it's being delivered, firstly. And secondly, they're the ones that need to maintain that. So as systems change, as equipment on the factory floor changes, you're going to need to go in and make changes to the Intelligence Hub. When a system like this is only owned by the IT team, you end up spending a lot of time chasing problems. So as changes happen in the factory, you end up having to go in and you know, the IT systems don't know the changes happen until the data is not there, and then you try to troubleshoot it. a system like HiByte can be used as a proactive system to be able to deliver that data updates, and actually can be part of the delivery of a new piece of equipment or of a change to the logic on the PLCs. So we see this as being something that the OT team would use, but it would be used in delivering the data to the IT team. And certainly, if people have other thoughts, this is definitely an evolving area, and we'd be interested in having those discussions and hearing what others are experiencing.
Great. I have a good question, which the timing is very apropos after this morning's product strategy meeting, focused on kind of the roadmap and where the product's going. So I'll ask, how do we handle different instances of HiByte nodes distributed on the network? And maybe you can talk a little bit more about that, either John or Aaron.
Yeah, it's a timely question. It's what we're working on now. It's our main feature for 2.0, and actually we're just having conversations with the tech team on that user experience today. So what we have in 2.0 now, 2.0 isn't released yet, right? That's coming. But what we do have is the ability for a headless HiByte instance to run in a Docker image on a remote node and connect back to a central instance that could be used to configure that. So you can imagine you'd have a central portal that you go into, and you could see all of your remote instances, manage those easily, move configurations in and out, and make edits. So that's kind of our 2.0 solution for having, managing multiple deployed instances of HiByte, and try to make that super simple, right? So if an instance crashes, you can bring another one up really quick. It connects back securely, push the configuration down, and make management of that easy. So if you're interested in that, let us know, and probably within the next, 3 or 4 weeks, month or so, we'll have early access to that 2.0 to get some customer feedback on those features. But that's something we're actively working on now.
To build on that, I'll just add 2 comments. One is the plan for the 2.0 release would be this summer, just so people can gauge when to expect that functionality. The other thing is that today, if you need to manage multiple, the entire configuration of HiByte is stored in a JSON file. So the way that people are doing it now is that they'll define a standard JSON file or a standard configuration, and take that JSON and then push it out to the remote hubs, and then restart those hubs, and then configure as appropriate for the systems that hub is connecting to. So it is a little bit more manual, but there is some ability to move models across different hubs. But we certainly are looking to make that significantly easier, as Aaron just described in version 2.0.
Okay.
Next question.
Yeah, I think we have time maybe for one more. I know that we're already over on time, but we've had so many good questions, not to answer them. This one is, again, about the elusive sort of topic of UNS. Where does the UNS get defined? How does it get defined? And also the question comes up too, what's like the digital twin integration capability to visualize topics? Any thoughts on digital twin graphs in general?
Yeah, I can take a shot at that one. I'll probably get a C. I'll probably get a C on the test.
No, go ahead. There's no reason when digital twin is included.
I'm gonna get the class average. Yeah, I think so. Where does the UNS get defined? I think it's a great question. My personal opinion is UNS is a concept, right? And it's really appealing because we're really used to in a factory having a hard time getting to all the different types of data, right? So UNS, this idea that all the data is going to show up in this central place and we can just easily subscribe and get to it, like eureka, right? We're there. So the concept is really good. In practice, it turns out to be revolving around MQTT. But in terms of your question of where is it defined, I'm going to take that as like where are the actual data definitions and things defined. I look at HiByte as today we define those, we give you those data definitions, and we make sure that your unified namespace doesn't turn into the Wild West, meaning your broker address space is just a mess of people throwing junk in. So HiByte kind of orchestrates that. We're really interested as we evolve in how those factory-wide, corporate-wide definitions of data get tight, like restricted, tightened up, and like how they get enforced, right? So longer term, you'll probably see us work on some tools to help you define the UNS in terms of what those data definitions and topic namespace look like, and then how we enforce that to make sure like random data can end up in a broker. And then some kind of definition tool, digital. So digital twin, UNS and digital twin and those data definitions are definitely tied together. I think digital twin has a lot of marketing spin around it, but it's essentially the same thing, right? Like, how do I define what this machine looks like across my factory? What we don't have today that digital twin covers too is kind of like the ins and outs of like, I have methods I can call and data definite. We're more on the data definition side today, but you'll see us, we're definitely interested in integrating further with like Azure Digital Twin site-wise, like their data models as well. So you'll see like digital twin and this concept of a UNS are definitely coupled together. It's just the early stages of like how those integrations work to make it seamless. And we're in the middle of that for sure.
Yeah, I think that there's also.
That's a C plus, right?
I think that's great, Aaron. I'll give you a B plus.
All right.
My only comments are also going to be C-rated comments in that, or D, because it depends. And I've seen so many definitions of digital twin. Some people are approaching digital twin from a PLM standpoint and starting at the CAD models and documentation and really focus there. We're really focused on the real-time data and the real-time data maybe that's been put to rest for a little while in terms of stored in a database. How do we get that out and how do we deliver that to the target? I generally think of digital twin as a storage mechanism. So it would be maybe Azure or AWS in the cloud. You've got the CAD models, you've got all the different real-time data, you've got all the different documentation and whatnot. In which case we become the digital thread. So we're creating all the different pipelines of data flowing into that digital twin. But I've also seen some definitions that very much look just like what we're doing, where you're creating the structure to standardize and harmonize and structure the data so that it create the models, and people define that as the digital twin. So it can really go multiple directions. The key is to define what the use case is, what the customer needs, and then we can see how the Highbound Intelligence Hub can deliver the data that you need.
Well, the good news, guys, is that the person who asked the question gave you guys an A. So I think we're going to end on that high note.
Yes. Thank you, everyone, for joining us. Really excited to get everyone on board and listening. Apologize for going over, or I guess happy to answer more questions and go over a little bit. But once again, reach out to us. We'd love to have these conversations. We'd love to continue the conversation. We'd love to get the Intelligence Hub in your hands and get your feedback and get it deployed in your system. So thanks again for joining us. Thanks, Tori, and thanks, Aaron.
Thanks, guys. Cheers.